So in this tutorial I'll be talking about the loop filter. So this is what the block diagram of the loop filter looks like. So it's actually a more like a feedback filter that feeds back the output. So this is reason for the what they call it, the loop filter. So it continuously feeds back the output back to the input, then does some multiplication addition on it to give us the output. I drafted a little calculation for it here. So this is what this filter looks like. So this is the calculation for the filter here. The value of the filter, the input there is C. So here this is C. So let me show it further. I want to exactly this way. So the input to the filter is this C, and this is coming from our main circuit. I'll show you where we got this C from. This is where we got the C. So remember the initial diagram of the circuit. So what we have here, after the multiplier circuit, initially we get the C here. So that C is fed into the loop filter, and the output here is D1. Is what you're going to get outside of here is the D1. So pertaining to this circuit now, this is where that C comes in. This is the loop filter expanded, the C, then this is the D1 output. So this is the loop. Continuously it feeds back the output to the input, and while multiplying it by 15/16. So this is the circuit in logic sim. So this is the loop filter in the main circuit here, and you can see it gets this input. This C comes directly from the output of this multiplier, and then it produces D1 as its output. So I will expand the loop filter so you see what it looks like internally. So this is it. This is where the C comes in, and this is where the output D1 comes out. So here the output of this one here, I'll call it E, and the output here I'll call it D temp. Just for explanation reasons, I'll be making some explanations with them. Now this is the calculation for this loop filter. So this is C, the input, and this is the D. Okay, I actually interchange it. D1 is actually this should be D1, and this should be D2. So D1 is this D temp. I got temporary D at the end. The output here is D1. So let's see what it does. So first, this is the calculation for this filter. It's an integrator actually, like having the sigma notation. So it's more like an integrator. It keeps integrating this D term times 15/6 for every input you get into this C. It continuously adds this D term times 15/16. So let's just go through this little calculation here, one after the other. So this is the formula for the filter. Then expanding this 15/16, you get D temp C plus D temp plus 1 minus 1/16. Now expanding it further, sorry, I want to do something. Okay, now expanding it further, you now get C plus, that is opening this bracket, D temp times 1, D temp minus D temp times 1/16. So let's assume that E is equal to d temp times 1 over 16. Then you have d temp is equal to c plus d temp minus e. That is d temp minus d temp times 1 over 16. So at the end you get d temp times d2 is equal to d temp. So what am I saying? Now this is the output of your d temp, and is equal to this, or is equal to this c plus d temp minus e. Sorry, let me c plus d temp minus e. So now this is where the logic goes here. This is your c, your input c coming here. C, this is another plus. This is d temp minus c, that does the subtractor. This is your d temp coming back minus e. This is where the e comes from. E comes from here. So goes here and does the subtraction, then does the addition to give you d temp. So that is c plus d temp minus e. This is it. C here plus d temp minus e. This is where the e comes from. Here. This is your c. So, and what is e? We already know what d temp is, and we know that this is what c is. C is the input. Now e is d temp times 1 over 16, and d temp times 1 over 16 means d temp divided by 16, and 16 is 2 raised to the power 4. So division by 16 is equivalent to shifting to the right by 4. So that is what we did here. We actually shifted it 11 down to 4 instead of 11 down to 0. It's a 12-bit input, so we now took 11 down to 4. That is shifting it to the right, and that was how we got e, which is d temp times 1 over 16. Then this one, what we normally did here and here is what I describe as a sign extension. That is extending the MSB to complete. So assume you have an 8-bit input going into a 12-bit RAM, so you know you'll be running short of 4 bits. So you just extend the leftmost bit using the MSB because of the sign. So for this particular circuit is sign conscious. That is, if you have 1 at the beginning, it means a negative value. If you have 0, it's positive. So it's a signed circuit. So that's why they use the sign extension. If you have 1 at the beginning, you extend it if it's 0. So that is the same thing here. So now it's 11 down to 4. That is after shifting it by 4 bits. That is divided by 16. Now instead of taking it 11 down to 4, they now extended bit 11. Now this is bit 11 extended to the LSB 11, 10, 9, and 8. So and finally you have your D1, which is the output. I told you already that this also be D1 and is equal to this D temp. So this is where the D temp went in and went into this circuit. So I was thinking, let me do a little simulation so we see how this filter works. If you have any question, you can leave your questions in the comments. Let me get a clock. So what's the input C and the output? So if you like, you can actually compare it with these equations I've given here already to check. If you take C and compare it with this D1, that is C, and finally is D2, and you can know if the equation is correct, that is if it rhymes. So that is it about this particular explanation. Thank you.